think we're ready to get the meeting started with Chris Vaughan and the sky this month. Take it away, Chris.
Thanks, Paul. So the period I'm covering tonight is going to run from tonight, September 16th, to mid-October, October 14th, 2020. And as you can see, spoiler alert, there's going to be something about Mars in this talk. Before I get going, I'd like to, though, acknowledge some of the images that I'm using in my slides from members and friends, including Stu McNair, Steve McKinney, Michael Watson, and Lynn Hilborn. This image is background images of the Milky Way by Michael Watson. He has a fantastic gallery of astroimagery on his Flickr page. So if you search for Michael Watson on Flickr, you can pick up, take a look at some of his wonderful shots. In case you're you don't have time to listen for the whole presentation and just want the highlights, the bullet points off the top, here are the key figures. We've got longer nights this time of year. Yay, we've got 9 hours of imaging time for those that are into astroimaging. We were dealing with wildfire smoke lately, and I'll show you a map in a minute. It's now aurora season, so at this time of the year, the Earth's magnetic field isn't quite as able to fend off the sun's blast, so we tend to get a little more aurora around the equinoxes. We have Mars at its closest approach on October 6th and opposition on the 13th. There's a period of time where we can see the zodiacal light in the mornings, now and again a month from now. The Orion meteor shower has already begun, just dribs and drabs, but you can keep your eye out for some. They peak next month. And we have an occultation of the moon, of a star by the moon on September 30th. And lots of International Space Station passes. A little bit of news in space exploration. So it's to be determined when exactly, but in the next little while, we're going to see a launch by Virgin Orbit of their Launcher 1 rocket. This is the rocket that gets taken up into the high altitude on a Boeing 747 and then released, and then the rocket engine ignites and takes the payload to orbit, and it's going to be delivering about 14 CubeSats for NASA field centers, educational institutions, and laboratories. You can see the details there. And then on September 17th, that's tomorrow at 2:17 p.m., we have scheduled a SpaceX to launch more Starlink satellites. Yay, astronomers. And then there are a series of launches after that in the coming days and weeks of Starlink Series 12, 13, and so on. Finally, around the time of our next meeting, October 14th, we have the next crewed mission launching from Russia up to the space station. So that'll be a crew change happening around that time. Here's the smoke map. So this is coming from an app called Astrospheric, which was one of the apps I like to use for predicting observing conditions when I'm planning my observing sessions. And they have an option in the upper left corner of their web interface that lets you click for a map of the smoke conditions in your area. And you can see here I've got Toronto with a bullseye, and all the purple color would represent a high concentration of smoke, which is wafted in from the West Coast wildfires. They really kicked in around sort of Sunday mornings, Monday night. I was observing at the Carr Astronomical Observatory on Sunday night. The sky was fine, but Monday night it was very poor with transparency due to the smoke. Forecast right now is that the smoke is expected to diminish or to dissipate somewhat by Friday, which is sort of still in our dark skies week. So let's fingers crossed that we get a little break on the smoke. As I said at the top, we've got a period of time where we can see the morning zodiacal light, and this is a nice picture of it. This is this faint band of light you can see on the center left part of the image. This is taken by Stu McNair 2 years ago in October. And what the zodiacal light is, it's small particles of debris that are concentrated in the plane of the solar system. And when the ecliptic is quite vertical with respect to the horizon, then the sun can drop well below the horizon, and the sunlight scattering off these particles can be visible as a faint glow, sort of bracketing or saddling across the ecliptic. And it happens in September, October in the morning, and it happens in sort of March, April in the evening. So we have our first of two sort of windows for the zodiacal light happening between now and the full moon on October 1st. And I know you're thinking, well, if I'm looking for a faint band of light, why am I talking about full moon? And that's because the moon is on the other side of the sky from where it is. So we really get that opportunity to see it even while the moon is waxing in phase, just because it's half the world, half the sky away from where the zodiacal light is. So for about half an hour before sunrise or before dusk, before dawn, you can look east, and it's in the zone sort of between Venus, Regulus, and that sort of patch of the sky. There's another opportunity to see it on October 14th when the window again opens for 2 weeks. In terms of our observing time, our amount of dark, we've got sunset happening tonight at 7:24 p.m. Sunrise is around 7 a.m. So that gives us 12.5 hours of daylight. By our next meeting, 4 weeks from now, we'll have earlier sunsets at 6:34, and the amount of daylight will have dropped by almost an hour and a half. And you can see we also, in the meantime, we're going to have our northern autumnal equinox occurring on September 22nd in the morning at 9:31 a.m. And as I said, the Earth's magnetic field has a vector. It has north components and east-west components. And the north component of the Earth's magnetic field is a little bit diminished because at the equinox, the Earth's magnetic field is tipped a bit sideways with respect to the sun in our orbit. And that allows a bit more of the sun's energy to penetrate our protective magnetic barrier. And so we sometimes get enhanced aurora happening near the equinoxes. But what the imagers are really interested in are the dark, dark nights, the dark sky. And we define the end of astronomical twilight as the period when the sun is more than 18 degrees below the horizon. So the sky is as black as it's going to get. And that'll last until the sun starts to rise and it's more than 18 degrees below the morning sky, the horizon in the morning. So tonight or today, we've got the astronomical twilight ending at 9:02 p.m. and starting at 5:22. That gives us about 8 hours and 20 minutes of dark imaging time right now, and that's actually increasing by about 3 minutes a day. A month from now, that gets bumped to about 9 hours and 45 minutes of total imaging time. So we've got to fend with the colder temperatures, which is good for cameras, not so good for maybe the astronomers, but we certainly like the dark winter skies for that reason, lots of imaging time. And if you look at this graph through the year of the balance between daytime and nighttime, you can see we're sitting here in the fall, and the amount of daytime is sort of reducing and the amount of nighttime is increasing. It's the same principle, just in graph form. In terms of the moon phenomenon, we've got the new moon happening tomorrow morning at 7 a.m. That gives us another 1 or 2 days of dark evening skies before the moon starts to be bothersome again. The next first quarter moon will happen on September 23rd, and then the full moon, which is the harvest moon, will be on Thursday, October 1st. And the harvest moon is defined as the full moon that occurs closest to the equinox in the autumn. Last year it was in September, this year it's in October. And the last quarter moon is on October 9th. And just for good measure, the International Observe the Moon Night is going to take advantage of that first quarter moon and follow it a few days later on the weekend, Saturday, September 26th. If you're interested in the phenomenon of the harvest moon, so because the ecliptic, which is the yellow line I'm showing on my screen here, is very shallow in the evening time, and remember the zodiacal light has the steep ecliptic in the morning, so there's if one does the one and the other does the other. So we have the very shallow ecliptic in the evening, we have the moon's orbit sort of subparallel to the ecliptic, and so when the moon travels along its orbit day after day, it's doing a lot more left-right motion than it is up-down motion. And the result of that is that the moon only rises about 20 minutes later, night after night after night, around the full harvest moon. So here we have the rise times of the moon centered on October 1st, and you can see there's really only 21 minutes delay night to night around this time. And that gave the farmers and everyone else working in the fields a bit more time to work because they were being blessed by all that bright moonlight to help see their way. Now, just in case you're wondering, the moon normally rises much later, much more delay than 20 minutes. So around the winter solstice, the moon rises more than an hour later, night after night. Here's a graphical representation of the upcoming month, starting tonight's meeting here on the 16th. So we have good dark sky observing in the red windows, the red boxes, up until about Sunday. Then the moon's getting a little bit bright in the evening sky, and then we get to third quarter on the 10th of October, and that opens up another good 10 days or so of dark moonless evenings for us to work in. Now, the big news of the month is Mars. Mars is going to be reaching both its closest approach to Earth and opposition. And this is going to be, oppositions of Mars occur about every 27 months. And so the last time we had an opposition to Mars, 2 years ago, the whole planet was shrouded in dust. And so far, so good. We've been looking at Mars and it's still clear viewing. So we might be good sailing or clear sailing in this case. But this close approach to Mars is not quite as close to Mars as it was in 2018, but it will be the closest one we get for the next 15 years or so. And this is a sort of a top-down schematic of our solar system, and I've just enlarged Mars and Earth sort of just to give you a better and easier way of seeing them. And so you can see that the orbits of Mars and Earth are not concentric on the sun. They're both a little bit elliptical. And so you can see that there are places when the distance between the two orbits is narrower and wider. And so what happens that we're lining up on the same side of the sun in early October. This is actually the night of the closest approach. So the minimum distance between the Earth and Mars will happen around 2 a.m. on October the 6th. So that evening of the 5th and then into the 6th would be the time of the year, the moment when Mars is closest. So it's got its biggest disk, biggest size disk, and the distance at that time will be about 62 million kilometers, or less than half an astronomical unit, which is the astronomical unit is the average distance between the Earth and the Sun. And for those interested in radio signals and talking to spacecraft, it's almost three and a half light minutes time delay to communicate with Mars one way. So you can see there's a slight angle here between the Earth to the Sun and Mars to the Sun, but yet that's the night on the 6th when they're closest together. At that time, Mars will be at a visual magnitude of -2.56. As I said, it's going to have a disk size at a maximum of 22.5 second arc seconds. And just for comparison, if you've looked at Jupiter in your telescope, Jupiter will be about twice that. So Mars will be substantial, but nowhere near as big as Jupiter's disk. If you're observing Mars that night, Mars will be at its highest in the southern sky around 2 a.m. And at that point, it'll be about 51 degrees altitude, or more than halfway up the southern sky. Now, Mars's day is not quite an hour longer than Earth's day, when that means that if you look at Mars at the same time of the night, Earth time, night after night, Mars will have rotated a little bit less than a full rotation. So that means over a sequence of nights, you'll actually see slightly different sections of Mars. So if you want to look at Mars through a telescope on October 5th, 6th, here are a few of the major features that you can look for. You'll see the pattern of the south polar cap. So the southern polar cap, Mars recently started its southern summer, so the southern polar cap is actually shrinking right now, but it is tilted towards the inner solar system, so it sort of favored our view. The north polar cap at the other end would be kind of out of sight for us. So the south polar cap will look like a small bright point near the limb of the planet. And then you want to look for these bright and dark areas. I mean, you won't be able to get perhaps clear boundaries on them, but you'll be able to get a sense of a bright area, a dark area in your telescope, depending on the size and depending on the seeing conditions that you've got. So this is a picture of what Mars will show us towards Earth on that night of October 5th, 6th. You go for the dark, prominent, very dark area called Syrtis Major. You go for a very bright, sort of round area called Hellas. And then there are other Mare and things like that that'll create sort of a pattern. And it's fun to sketch what you see and then compare it to an app or a planetarium software to see if you can match it. Now, this this is taken from Stellarium, and what I've done is I've left Mars right way up. So your telescope, depending on its type, might flip Mars left and right, or it might flip Mars upside down. So if you have a Newtonian reflector telescope or a Dobsonian reflector telescope, it's going to flip Mars upside down, so the polar cap will be at the top. Okay. If you have a refractor telescope with a diagonal on it, then probably it might just flip it left, right. Same might be true for a Schmidt-Cassegrain telescope, one of the compound telescopes. Now, about a week later, on the 14th of October at 2 a.m., will be the exact moment of opposition. And at that time, the Earth will be between Mars and the sun. That means Mars rises as the sun sets and then sets as the sun rises. So Mars is visible all night long. It's past its largest appearance, but it's now at its brightest appearance. So Mars will actually shine at visual magnitude minus 2.62 that night. Its disk size will be slightly smaller than it was a week earlier, but it's not going to make any difference. So you really want to take advantage of that whole period from the 6th to the 12th, even starting a few days before and continuing a few days after. Now, Earth and Mars line up about every 27 months. And that means that in 27 months, the Earth will go around the sun twice and add 3 months more. So it's going to do another quarter of its orbit. So the next time Mars and Earth line up, you can see that the distance between the two orbits is much greater. And then again, much greater. And then we have to wait about 15 years for us to get back into the time when they line up, where the two orbits are closer to one another. So a week later, as I said, on the 14th, now Mars is going to be transit or culminating or high in the southern sky at about 1 o'clock instead of 2 o'clock. So you can actually start, seeing it a little bit higher earlier in the evening than it was. And it'll again be about 51 degrees high. And in a week, the amount of rotation of the planet will produce a slightly different view. Here is still the Hellas area and the Syrtis Major, which shall now be sort of tucked into the top corner. And again, it might flip in your telescope. Now we've got another area called Hesperia, and you might even be able to see this little dark Mare here. And we're getting into the Tharsis and Mount Olympus Mons and mountain area later on. So keep watching even beyond the 13th, 14th, and over the course of, you can also, look well into the night and see more Mars rotation, or you can look night after night over the course of 10, 15 days and really get to see almost the whole planet, except for the extreme northern part of the planet by doing that. If you want to find a nice map that's annotated, which shows the names of all these features much more than I have here, here's a link here. karmalimbo.com, Aeropix, Refer, Mars Map Hole is a nice one that I used in preparation of the talk tonight. Just to give you an idea of the brightness of Mars and the size of its disk in your telescope. So here's how Mars looks through the year 2020. And you can see that the angular size of the planet will peak here on October 6th. And then about a week later, these two graphs are offset about a week. That's when it's going to be at its brightest. But again, around this time. And you can see that it's sort of slowly ramping up in size and brightness, but it's going to drop off a little faster. So you really want to take advantage of this period and get a look. But bear in mind that in the weeks following opposition, Mars will actually stay higher in the sky. So it'll actually be up in an observable height at a much more convenient time, even though it might be a little less bright and a little less large in size. Meteor showers that are coming up this month. We have the Draconids meteor shower that's running in early October from the 6th to the 10th. Start watching that one right after dusk, because the radiant for that shower is in Draco, which is in the evening sky, high in the evening sky. You want to watch for meteor showers when their radiants are well above the horizon. Otherwise, you're missing meteors that are hidden by the bulk of the Earth. And so the Draconids shower is best to view in the evening time. This is a highly variable shower. It's not a major shower of the year, but you want to keep an eye out. You may see a few. I'm not sure how many you'll get this year. And the peak night to watch is sort of the 7th and 8th. There is a waning gibbous moon that will rise at about 10 p.m. So, start looking as soon as it gets dark and keep an eye out for them, because by the time you get into late evening, you're going to be competing with the moon. As I mentioned, the Orionid shower is a long duration shower. It starts around the 27th of 23rd of September and runs into late November. But of course, meteor showers ramp up and then they have a peak. And the most meteors occur around the peak nights, around the peak night. So the peak for the Orionids isn't until the next person's sky this month. I think that's Arnold Brody. So he'll talk about it, more of it then, around October 21, 22. Luckily for us, the moon will set early that evening, and the Orionids are a midnight to dawn sort of a best time. So the moon will not be competing with them at all. Tip for meteor watching, the radiant of the shower is the apparent source of the sky or where the meteors are emanating from. Give the shower their name, but you don't want to watch the radiant because those meteors are coming straight at you and they won't have very long tails at all. So you really want to get an open sky and watch anywhere you just pay attention to the whole sky. Don't use binoculars, don't use telescopes for meteors. So there's a picture from a NASA astronomy picture of the day showing how the meteors are radiating from the constellation of Orion here in the middle. If you're wanting to see the International Space Station, we're currently in a very busy set of evening passes, lots of very bright passes. So the magnitude number, the more negative it is, the brighter the space station will appear to your eyes. And a -3 or 3.9 is extremely bright. So brighter than Venus, which is a bright planet. Here's a list of when some of the brighter ones are coming up. You can see that they're mostly sort of in the 8:15 to 10 p.m. range, so at a nice convenient time. The space station goes over around the Earth every 90 minutes. It's constantly passing overhead, but we only can see it when the sky is dark and when the sun has gone down, but the space station can still see the sunlight. It's still bathed in sunlight. So it's really post-sunset and pre-dawn. And if you want to find out when the space station's visible wherever you are, the best advice is to go to the website called heavens-above.com, enter your location, and then click on the link. There are links to various satellite sets, but you want to click on ISS, and it'll give you that table showing you when it rises, when it's at highest, when it's at lowest, and its brightness, and so on. I also summarize when the space station's passing over in my weekly Astronomy Skylights newsletter designed for the GTA areas. So if you're wanting to check that out, you can receive it in your inbox, or you can go to astrogeo.ca/skylights and see the list of them there. The moon is going to occult or pass in front of a naked eye star on September 30th. The star is named as 33 Piscium, or it's in the constellation of Pisces, so it's the genitive of Pisces is Piscium. And that will happen from 8:10 p.m. The sky won't be quite dark yet until 9:20 p.m. when it'll pop out. So at 8:20, the moon will cover the star here, and by 9:20, the star will reappear from the opposite side of the moon. Now, the moon's about full that night, but the star should be readily visible in binoculars and certainly in telescopes. Just don't magnify the moon too much so that if you're not clear exactly where the star is going to reappear from, you don't want to zoom in on the wrong patch of the moon and then miss it. So just use a sort of a full-sized or a full view of the moon and then watch for that star to reappear. There's another one happening on October 3rd. That's a different star. That's the star New Piscium, and that's going to be in the after midnight time, so it's not as convenient. All right, I'm going to switch to Stellarium and give you a little tour of what's happening to the moon and planets. Right now we've got in the morning sky, which I'll switch to here. If you've been up early, you'll have seen, let me get over to the east here. Here we go. Venus has been gleaming in the eastern sky for a number of months now. It's already finished its greatest elongation from the sun, and it's now swinging back towards the sun to superior conjunction. So while it's swinging sunward, it's also moving a bit farther from us. It's going to end up on the far side of the sun from us. You can see that night after night, or morning after morning, I should say, the planet is dropping with respect to the background stars. So it's currently among the stars of Cancer, which is tomorrow morning here. And then it'll be dropping down and heading towards Leo in the next couple of weeks. So Venus rises about 3:30 in the morning. Its disk size, which shows if I can get you a close-up of Venus here. So you can see it's a gibbous phase. It's actually waxing slowly, gradually, so it'll look about the same as this for a number of weeks, and it'll stay visible in our skies until about mid-December. On the 22nd of the month, it's actually going to pass fairly close to the asteroid Vesta, about 2 degrees south of Vesta. And then in early October, it's going to pass on the sort of the 2nd and the 3rd. It's going to be less than a finger's width away from the star Regulus, if you're interested in seeing something with a planet and a star in the telescope at the same time. All right, let's go back to now, and I'm just going to bring up Mercury here. So Mercury's been lingering in the western sky after sunset for quite a while now, but you can see because of that steep evening ecliptic, we really can't see it. It's really hugging the horizon for us. But if you live at a southern latitude, so there's Mercury there. If you live at a southern latitude or in the southern hemisphere, Mercury is the ecliptic for you is very vertical, and so you can see Mercury at its best for the year. But this is one of our worst appearances for the year. So Mercury is going to swing away from the sun until October 1st, and then it'll be gone for good until we get our next morning appearance of it. But of course, what everybody's been noticing a lot lately is Jupiter and Saturn. So Jupiter and Saturn have been hanging around here in the southern sky after dusk, not too far from the Milky Way, if you've been able to escape the city light pollution and get into a nice dark sky. Right now, Jupiter and Saturn are about 8 degrees apart, so that's less than your fist held at arm's length with one eye closed. But actually, Jupiter's faster orbit is allowing it to sort of creep closer to Saturn. So in the next month, that's going to reduce to about 6 degrees. And then by the end of the year, they're going to practically touch in the sky. They'll be so close together, it'll be crazy. Jupiter's about 10 times brighter than Saturn, so you've got to wait for the sky to get a little darker before Saturn pops out. If you want to look at some of the neat features on Jupiter, of course, you've got the Great Red Spot. The Great Red Spot takes about 3 hours to cross the planet, but that's only visible about every second or third night for us because Jupiter's day is only 10 hours. So by the time we've done 24, it's done 2.5 revolutions. So we got to wait for the red spot to reappear. You can also catch a few of the shadow transits where the Jupiter's one or more of Jupiter's little Galilean moons cast their round black shadows on the planet. And again, those take 2 or 3 hours to cross the planet as well. And if the air is steady and you've got a reasonable sized telescope, a 3 or 4 inch diameter aperture telescope and good seeing conditions, you can see those little black spots as well as the Great Red Spot on the planet. Saturn is going to, right now Jupiter is moving kind of retrograde west in Sagittarius. Saturn is going to join it in doing that at the end of the month on the 29th. And that'll allow these two planets to start sort of closing in on each other. Just to recap Mars for a minute here. So if we go later in the evening, so Mars is now rising at about just before 9 p.m. now, and then you can follow it all night long. It'll be the bright, eye-catching reddish object in the eastern sky in early evening, and then right now by the middle of the night, it'll transit in the south about 3 in the morning. So, if you're getting up to go for a drink or to visit the washroom in the night and have a south-facing window, you might catch this bright gleaming object, and that'll be Mars shining in the window. All right, now the ice giant planets, Neptune and Uranus, sort of bracketing Mars in the sky. So they're kind of middle of the night objects as well. Neptune, we have here, Neptune is near a naked eye star named Phi Aquarii. This is Phi Aquarii. So if you have binoculars, you can look for these two these are Psi Aquarii, these two stars close together, Phi and Hydor. Make a little triangle, look for this little triangle, and then Neptune is going to be sitting off to the left or east of them. Neptune is pretty dim, so you probably want to put your telescope on it. In a telescope, it'll show the distinctive blue color that we all love. Neptune has recently passed its opposition within the last couple of weeks, so it's actually closest to the Earth and largest in its disk for the year. And that gives you potential to see Neptune's moon Triton. Let's see if I can bring Triton into view here. So Triton is this rather prominent moon. And the time you want to see Triton is when it's farthest away from the glare of the planet. Again, you need a big telescope and good seeing conditions. But that happens around every third night or so. So you can use a planetary map like Stellarium or something to work out when your odds would be the best of seeing it. And let's just run back to Uranus. So Uranus is bright enough to see in binoculars, even naked eye if your sky is ideal, but certainly binoculars and backyard telescopes. It's in the constellation of Aries. So you can look for these brightest stars, Hamal and Sheridan in Aries, and sort of it makes a narrow, a skinny triangle below them in the evening sky. And it's visible all night long. So what I thought I'd do is just give you a few photo ops that you can look out for. For that, I want the moon. So we've got the moon here passing the sun. And just bring this into view here. And the moon will be disappeared for the next couple of days. The next time we can really see it will be sort of Friday, Saturday time frame. And as we go through the month, so it'll make a nice grouping with Saturn and Jupiter on the 24th and the 25th. And that's a neat instance where you can sort of wait a bit later in the evening where they're closer to the horizon and you can sort of compose a great scene with some interesting foreground landscape. Then on the 2nd of October, we can see the moon sitting very, very close to Mars. And what's neat about this is that, let's see how long, when do they set? So they don't set until the sunrise. So you might even be able to get a chance to find Mars in a brighter sky using the moon as a help to do that. If I just take away the landscape here for a second. So you can just look a few degrees to the lower right of the moon and see if you can spot Mars before they set. And let's go back a few more dates, a few more nights. The moon's going to pass through Taurus, through Gemini, through Cancer. So on the 11th, you can look for the moon sitting just near the Beehive cluster, Messier 44, in the pre-dawn sky. The trick there is to hide the moon outside the view of your binoculars and see if you can spot the stars below it. And then a couple of mornings later, we have the moon partnering up with Venus in the morning sky, another nice photo opportunity with a beautiful, pretty crescent moon in the morning sky. What I thought I'd leave you with now is highlight an interesting constellation to take a tour of at this time of the year. And that's the constellation of Cepheus. I'm just going to come back to the evening sky here. Let me turn off my orbits to make it simpler. All right. So Cepheus is a circumpolar constellation. So here's Polaris down here. And Cepheus is the king of in Greek mythology, the king of Ethiopia. His wife was Cassiopeia. Their daughter was Andromeda. And that led to the whole story about Andromeda and Perseus and Pegasus and the whole story. The whole family are up in the sky together. So even though Cepheus is circumpolar, it's always above the horizon for us. At this time of year, sort of September, October, November, December, in the evening sky, Cepheus is at its highest. We always want to look at objects when they're highest in the sky, because then we're viewing them through the least amount of Earth's atmosphere, and we get the clearest view of the object. So what I thought I'd do is give you some interesting aspects of Cepheus to look at. So Cepheus, you could start with Polaris, and it's the constellation right above Polaris. Another way of doing this is to look for Cygnus the Swan or Cassiopeia. and sort of look below and between those two constellations for him. So the brightest star in Cepheus is Aldebaran, which is the Alpha Cephei. It's an Arabic name for the right arm. This star is unique in that it has an extremely high rotation rate. It rotates once every 12 hours compared to the sun, our sun, which rotates once every 27 days. Off to the side here, we have stars that are sometimes meant to represent the king's arm, outstretched arm. This is Eta Cephei. And then below that, we have his hand. I'm just going to turn off the deep sky object so you can see a little better. Then sort of his elbow and his hand would be these two stars reaching out. So those Eta and Theta Cephei. Now heading back to Aldebaran, we can head down to Alpherk. So Alpherk is the beta star in the constellation. It's a pulsating variable star. It's about 690 light years away from us. Hot blue-white star, 10 times the mass of our sun. It's got two close-in companions that are too close for a telescope to see. But this star actually pulsates in brightness every 4.5 hours due to iron enrichment in the star's interior. So it's got a unique aspect there. Then heading down to the bottom, we sometimes think of Cepheus as an upside-down house. So you've got the house with the pointy roof. So this would be Eri, would be at the point of the roof, or this is also known as Gamma Cephei. It's an orange K-class star. It's about the same brightness as Alpherk. And what's neat about this star is that in 1988, Canadian astronomers detected the signal of an extrasolar planet or an exoplanet around this star. And that would have been the first confirmed exoplanet in history. But the data wasn't definitive enough, and they weren't willing to publish on it and claim the discovery. So that honor went to the star 51 Pegasi a few years later in 1996 or so. But now we've got better data, and we have confirmed that the star has a planet. That was confirmed in 2002. And that planet has been named Tadmor. That means it's an ancient Semitic name for the city of Palmyra in the country of Syria. Now heading back up the roof, we've got Iota. Iota is another orange class star. Again, these are all about the same brightness. And head on up. Okay, so this is Zeta. Zeta is the other corner of the box. And Zeta has a magnitude of 4.2. So it's about here. Sorry, its magnitude is 3.35, sorry. But what's interesting is that there's a little star named Epsilon that has a dimmer magnitude of 4.15. And down here we have Delta Cephei. So Delta Cephei is the star that was the basis of the Cepheid variable system that you may have heard of. So these are stars that have a known relationship between their variability period and their brightness. And in 1912, astronomer Henrietta Swan Leavitt of Harvard discovered this relationship, and knowing that, she was able to determine the distances to various Cepheid variable stars in the universe. And we've actually discovered Cepheid variable stars in other galaxies, which is an assistance to determining how far they are. Now, yeah, so Delta Cephei varies in brightness between these two ranges that match Zeta and Epsilon. So next time you're out, take a look at Delta Cephei and see whether you think it's at the peak of its brightness or the minimum of its brightness. If you've got your binoculars, take a look. There's a lot of nebulas and clusters because Cepheus borders on the Milky Way. One of the most interesting ones is this patch above the box of Cepheus, where we have the Garnet Star, or Mu Cephei. This is a massive star, many thousands of times bigger than the sun. It's thousands of light years away, but it's so luminous that we can see it with our naked eye. And it's one of the reddest stars you can see in your telescope. So there's a little bit of a tour of Cepheus. It's the perfect time of the year to see it. And with that, I'll end. Thank you very much.
I believe I was muted there. Should I repeat? All right. Sorry, I was on mute unknowingly. I was saying, Chris, thank you so much for the time and effort you put into the presentation. I know that it takes an awful lot of time to prepare the presentation because of all the research you have to do. So thanks again. Let's go to maybe a couple of questions. We are running a little bit late, so let's just curb it to 2 questions for now.
Okay. Joel asked a question. He was out last night around midnight and he saw Mars. It was very bright, but he couldn't find Jupiter. So I think the question is, what time is Jupiter, or are Jupiter and Saturn setting right now? Or was it possibly the smoke that was interfering?
I think the smoke could have hidden Saturn, but not Jupiter. When I was at CAO, I could certainly see Saturn was struggling to cut through the murk. The thing about Jupiter and Saturn right now is we're losing their window, our observing window for them. So really, by late evening, they're already sinking into the west. So it's possible that he was just waiting a little too long. So Jupiter right now is setting at 11:30 p.m. Oh, sorry, let me go back to today. Here we go, back to tonight. So Saturn is setting at 1:17, but really at midnight, it's getting kind of low in the southwest.
Yeah, so any clouds or smoke down there would make it challenging.
Yeah, horizon cloud, sure.
And I had a question for you. What's your current GRS setting, the Great Red Spot setting in Stellarium that you're using?
So the way you find that is you click F4, the sky and viewing options, go into solar system, go into custom GRS settings, and I've got 188. I haven't checked that lately, but that's what I'm using.
Okay, thanks.